All right, so you may have collected your own data in lab yesterday. We want to make sure that we have enough. So you're going to use this backup data set, okay, unless you come and talk to your teacher and you show me you have enough data to use your own, and then you can start with an empty spreadsheet. Okay, but from this data set, what we need to do is start analyzing this data. Okay, we collected information about what type of insulation we had, how thick it was, the mass of the water in the canister, and the temperature before and after it was in the canister. Your experiment was a little different than mine. I started with room temperature water and put it in a cold place, whereas you started with cold water and did it the other way. But the results will still help us determine which type of insulation and which thickness is best for our experiment. So the first thing I need to do is find the change in temperature. Remember, we want to make the computer do it for us, so I will have it, I'll write an equation. I'll start by clicking equals to write an equation, and I'll just do the final temperature minus the initial temperature and press enter. And then I'll go ahead and drag this down so it calculates it for all of my values. And so all of these make sense. They're all negative because all the temperatures are going down. Okay, pause the video, go ahead and do that step yourself. Now that I've got the change in temperature, I need to find how much heat did the water actually lose in this process. And I know from my notes from before is that Q equals Cm delta T. And so I just need to write an equation for Q. So it's going to be equals C. C is the specific heat, and the specific heat of water is a constant at 4.18. So it'll be 4.18 every time, times the mass. Okay, the mass of the water is right here, times the change in the temperature, which is right here. And so I got 4.8 times D3 times G3. That seems right. Let's see. Specific heat times the mass times the change in temperature. So I'll press enter, and I'll go ahead and drag it down for all of these. Okay, they're all negative. They all look good after skimming it. Okay, go ahead and pause the video and do that step. Now I'm going to change that heat into a heat flow rate, because that's really what we want to know. We want to know how fast is heat moving through this. So the heat flow rate is just joules per second. Here are my joules, and it was in for 600 seconds, which is 10 minutes. I did my experiment for 10 minutes, whereas you only did yours for 5. So we'll go equals this heat lost divided by the amount of time it was in the freezer for me. And I'll press enter, and then I'll go ahead and drag this down. And so now I have a heat flow rate for all of these. Okay, pause the video and do that step yourself. Now I need to find an average. So I'm only going to find the averages for trials that were the same. So the first 3 were all water, and they were all 2 centimeters thick. But I got different answers, so I just want to find an average answer. So I'll just type equals average, open parenthesis, highlight the 3 things I want to find the average of, close parenthesis, and press enter. Okay, and then I'm just going to go ahead and drag that all the way down. Okay, I programmed the spreadsheet to do this color thing. It will just let you know, like, the darker, it's comparing all these numbers together, and so the darker red it is, the more heat it's letting go through, or letting in. And then the lighter the green, or the darker the green, the better an insulator it is, so the less the heat flow rate is. So we can already get a good guess at which one of these is the best and which one's the worst. So this one, this paper is probably the worst. Okay, and then this plastic bag at 6 centimeters is probably the best. But we'll do some more data analysis to figure out if that's true. Okay, pause the video, find the average heat flow rate for everything. Now I'm going to start making scatter plots of this data, because I want to know how much better does it get as the thickness increases. So I'm going to compare my thickness to the heat flow rate. There are 2 ways to do this. I'm going to show you both. The first way is to make 4 different graphs. Okay, so we'll make 1 for water, 1 for cotton, 1 for paper, and 1 for plastic. So I'm going to start with water. I'll highlight my thickness data, press my control key, and I'll highlight the heat flow rate, data. So I grabbed both of those, and now I'll click Insert Chart. And go to Chart Types, change it to Scatter. And then I'm going to do some quick customization. I'll give it a title. This is the heat flow rate of water insulation. And I'll go down here. My horizontal axis, that's the thickness, and measured in centimeters. The vertical axis is the heat flow rate, measured in joules per second. And we'll go ahead and add some more grid lines. So I'll change this to 10. Go back up to my horizontal. Change the grid lines to 10. Okay, that way I have more lines in my graph. The big thing I want to do though is get this trend line added on here. So I'm going to go scroll all the way down and select linear for trend line. I see my line comes on here. I don't like this label though, so I'm going to make sure the label is the equation. And I do want to see the r² value. And so that looks pretty good. I see titles, I see axes, I see scales, I see points, and I see good labels. So I'm going to go ahead and insert this. Remember, I don't want it sitting on this graph though. So I'm just going to scroll over, click on it, click on this arrow, and move it to its own sheet. And since this one's water, I'll just type that water insulation. Okay, now that I've done that, okay, I can go back to my insulation data. Oops. Give it a second while it reloads. So I've got my water graph. Okay, now I can go back to my insulation data and I can do it again for cotton. Okay, highlight my cotton data, highlight the heat flow rates for cotton. Okay, and then I would just make the graph again, change the labels. Okay. You'll do that 3 more times so that you have one for water, one for cotton, one for paper, and one for plastic. Okay. Go ahead and pause the video and do that. Or you can continue watching and learn how to make a more complex graph. Okay, but it is more difficult to do this next step, and it is optional. Okay, the more complex graph requires making a new tab. Okay, and we're going to write thickness out. My thicknesses were all 2, and then 4, and then 6. Okay, and then I'm going to have the heat flow rates for my 4 materials. So it's water, cotton, paper, and plastic. Okay, go ahead and make this table. Now I'm going to go and grab the insulation data. So I'm going to highlight my heat flow rate for water. I'm going to copy it by pressing Control-C and go to my new data sheet, press titles for water, and press Control-V to paste it there. It doesn't like that because that was an equation before. I just want to paste the values. So I click on this little clipboard with the paper, click Paste Values instead. So I'm going to go ahead and do that for the cotton, paper, and plastic as well. Okay, grab this data, paste it here, paste values only. Okay, and then do it again for this. Paper, paste values only. Okay, and then one more time. Paste, but paste values only. Okay, so now I've got all of these. When I highlight all of this and click Insert Chart, it's going to allow me to make a more complex table. So we're going to go to Chart Types and scroll down to Scatter. And so now you can see it's got 4 different types on here. So let's do some quick customization. This will be the heat flow rate of different thicknesses of insulation. Okay, and my horizontal axis is still the same. It is thickness in in centimeters. Get that to have 10 grid lines. And then I'll go back up to my vertical axis. It's still the heat flow rate in joules per second. And change this to 10. And then the last part is just to add all my trend lines. So if I scroll down and I see series here, this one's going to do it just for water. So I'll click trend line, linear. Okay, make the label of the equation, show the r squared value. Okay, and then when I scroll back up here, I'm going to change the series from water to cotton, and then I'll do it again. So I'll add another trend line. Okay, have it use its equation, show the r squared value, and I'll repeat it for paper and plastic as well. Linear, use equation, show r squared. Okay, and then do it for plastic. So again, this one takes a little bit longer to do, but the graph is prettier. It shows all the information in one place instead of on 4 different graphs. Okay, I'll go ahead and move it to its own sheet. Okay, and then notice I can't see all the numbers on here, so I'm just going to change this font size to 11 instead of 12, and now I can see all the numbers. But this has all 4 of these on the same graph. It is more helpful than having to look at 4 different graphs over and over again. Okay, and so we'll call this one all insulation. This graph. Okay, so go ahead and choose between either making this graph with the 4 lines on one, okay, or you can make the more simple graph, but you have to make 4 graphs instead of just 1. It's up to you. Both of them count. Go ahead and rewatch any parts of the video that you get stuck on, but you need to analyze all the data on the spreadsheet and make graphs graphing all of this data, either 4 graphs or 1 graph. Okay, you can start.